Hello, everyone. Welcome back to another episode, and this is the fourth episode of our optimization algorithm series. And here in this video tutorial, I will explain about improved gray wolf optimizer, how it works. So, first of all, let me show you from where you can get this code. So, this is the source files. Now I will put the link in the description, and using that link you can easily download the files. So let me explain how does it work initially. So as most of the optimization algorithms work just like the social behaviors, and it's just like the working as social behavior and hunting patterns of the gray wolves. So initially, in the start of this program, we have initialization, where we have to initialize our number of search agents and iterations, minimum and maximum. And then there will be some kind of objective function evaluation, just like here. And then there is some kind of fitness function, which is actually included in the uh, function evaluation. And then there is some kind of movement, which we can say that leader wolf movement or pre-hunting. So based on our initial fitness values, we have to find the another fitness or another size and location for our updated wolves. And then there will be some kind of termination criteria, and at the end of this program we have to print the results. So let's get started. So I already have made a video on the basics of MATLAB program, and you can see that link in the I button. And if you are new to MATLAB program, just make sure to watch that video first, so you can get more uh, idea about the MATLAB commands, and in depth you can see how program works. So in the start of program, we have just started with the uh, clear commands, and then here, and here in the start of program, let me start with the debugger, and this is the main file. Let me this is, sorry, the main file. So just I have start debugger. Let me left click here, and algorithm name is just considered as IGWO, which is actually the improved version of Grey Wolf optimizer. And in simple Grey Wolf optimizer, uh, the improved IGWO is just improved in the convergence speed and some exploration balance, and it's just updated from its previous variant. So now we have number of search agents, and then next we have the function name. So as this program is designed by uh, Sayyid Ali Miraj Ali, so here we have a choice that we can choose between the f1 to f23. So if you can see here in the get function details, here we have different kind of functions. So it depends on the case. If we have different kind of objective functions, or within our objective function we have different cases which we want to include. So here you can see there are 23 different cases. But if you want to apply this optimization algorithm to your own case, and in that case it will be your own objective, and it depends how many cases you have. If you have one case, then you have to deal with only one. So here we have just initialized that function name one. And if you want to check this code for any other functions, just you have to rename it 5 or up to 23. You can change this to any function, and which function you will put here, it will work accordingly to that function. So make sure before after doing any changes, just click save. So we are here, let me click on run, let me click on step. So our function name is saved here as the f1, and maximum iterations are 500. And now at this point we have just input as our function name, and this function name is going to be inside this get function details. So we are going into this file, get function details. Let me start debugger here, and let me click on step. And here we are in cases switch f, so we are into f1. Let me click on step, and we are into this file. Here we have lower bound and upper bound, and here we have dim, which you can say that this is the dimension. So it's actually the variable which represent the dimensionality of the problem space. So these are the input, and let me click on step. Okay, and all the other cases will be skip. This loop is ended. Let me click on step, and now we are back to this uh, get function get function file. And one more point is there, as we have selected the f1 case, and our function starts from the line number 27, which is actually about the get function details. And this function right here is ended at the line number 170. So this is the function which is get function details. So our this function is ended right away. So let me click on step here. We are into this function, and after this line we will be out of this get function details.m file. So here we are out, and here our outputs are the upper bound, lower bound, upper bound, dimension, and fobg, which is actually the function name. So let me click on step. We are out now, and here we get that data from the get function details file. Here you can see that. And now after that we have added the this n, which is actually the number of search agents, maximum iterations, and all the other data which we get from the get function details. And now we are into our IGWO file. So IGWO .m, we are in now into we are going into this function file. Okay, so here is the IGWO, and let me click here. Okay, let me click on continue first. Okay, there is some kind of error. Let me tackle that first. Actually, there was a slight error in running the program, and the problem was that here in our program we have I underscore GWO.m. So just make sure we have exactly same name, and that name should be here. Because we are calling this function, and we have to go into this file, so it should be exactly the same name, and here it should be without .m. So we are here up to this point. Let me click on step. Okay, and after that here you can see that it's I underscore. So now let me click on step, and now we are into this file, and here all our inputs which we have entered into this IGWO file. And here is some evaluation for our lower bound based on these details. Let me click on step, and here we have created this program creates 2 rows and 30 columns. So we have different kind of numbers here. These numbers are actually, we are creating ones. How many ones? Actually 1 row and 30 columns. So we are creating here 1 row and 30 columns of ones, and this is the first one, and this is at the second number. So whenever we have a number separated by semicolon, so it means that, let me show you. when we have a numbers separated by this semicolon 5 3 for example, and 7 9, so it means that we are creating some this kind of content. So this will be the first row and this will be the second row. Let me show you that too with the MATLAB program. 5 3 and semicolon 7 9. Okay. Let me show you that in a simple way, that this is the first section. Let me copy that and let me paste into this command window, and here you can see that we have one row and 30 columns. Similarly, if I copy that command and put here, we have another 30 rows and we have one column. Okay, let me show you that. So here similarly we have right here two rows and 30 columns. So we have these numbers, and similarly we are going to initialize alpha, beta and delta positions. So that alpha, beta and delta positions, normally we say them as the different stages for this algorithm. And in alpha position we have initialized this variable. Let me click on step. Currently it's not initialized yet. Yeah, alpha position is initialized, and then here is the alpha score. So this will be the number which we have to put into objective function, and this will be its output. Similarly, we have beta position and beta score, which is infinite, and initially it will be infinite, and when uh, any of the first number is evaluated and it converge, it give us the number, and that number will actually be less than the infinite. So in that case we will update this infinite with that number, and this happen when we are going to minimize our objective function. And in case of maximization we have to put here 0, and then the first evaluated number or value, we will replace 0 with that number. Okay, and here is delta position for delta position zeros, and here the delta score is infinite. These alpha, beta, and delta actually are a major part of this IGWO, and it's a kind of theoretical part. So, for example, alpha vol means that they are the leaders of the pack, which represent the best nouns solution found initially, and then there are beta wolves, which are actually the secondary leaders in the wolf pack. And in delta wolf is another leader, but they are uh, less influential than the alpha and beta wolves. So all these three works with each other, so we can get the better numbers and get the best input and initialize the position of the wolves. Let's click on step, and we have initialized the position of the wolves, and then the calculate the objective function for each wolf. Okay, and here is the now we are going to calculate the objective function for each wolf. Let me click on step, and here we are calculating the fitness value for our objective. So here there is a call of FOBG, and in FOBG here you can see that we are calling the F1 function. So let me click on step. Okay, so that F1 function, as I explained previously, that this function is actually ended at the line number 170, and that is related to get function details. And here we have another call for FOBG, so which is actually the F1, and F1 is starting at line number 174. So if we have F2, that will be directing to this 180. And let's see at the end of this program, here we have 23 functions call. Each section is mentioned separately. So let me click on step here, and here we have find some O, and then there is some let me click on step, and now we are out of that. So the output which we get from that F1, we have here in form of FIT. Let me click on step, and FIT is initialized, and at the first position we have FIT. So size of, let me calculate how much is it. So it's 30. So 30 times this loop will be repeated itself. Okay, step, and again we are here, click on step, we are out, and now we have another fitness function value. So just like this, we have 30 numbers here. Let me left click here, and let me click on continue. Let me remove that. Okay. Now we have different 30 different fitness values based on our input or based on our position. And here we have in case of positions, let me show you the inputs. So in position, we have our inputs. So that inputs are, we have 30 rows and we have 30 columns. And in the positions which we have created right here, we have 30 rows and 30 columns. And using that, each time we have 30 values, as we have repeat this loop for 30 times. So each time we are considering the 30 numbers. Okay, and let me show you this one more time. Let me click on, let me remove that. Let me click on step. Let me click on continue. Let me click on step, and here right in the position we are considering the uh, first row and all the columns. So let me copy that, and let me show you that. So we are considering the first row and all the columns. Sorry, I just repeated. So we are just considering the first row, minus 39.86 and minus 99.3. So we have to repeat this loop for 30 times. So first time it will consider these 30 values to evaluate the F1 function from here at the line number of 175. And similarly it will move further, and next time it will consider these 30 numbers, and it will create it will evaluate the another fitness value for these numbers. And let's click on continue, and now we have the FIT, we have the 30 numbers, and here we have the FIT. Let me open the FIT. So in FIT we have currently the 30 numbers right here. As we have run this loop for 30 times, and we have 30 numbers, but we put that numbers in one row and 30 columns. So this first one, which is actually right now in the FIT, we get from these 30 numbers. So now we have all our FIT 30 fitness values or our costs, and now we want to put that into the P best score, which is actually you can say the personal best for all the wolves. So they are the personal best fitness and the position obtained, and all the positions which we get, we are going to put into the P best. And there is some neighbor and convergence curve. Initially, here is the start of the main loop, and it will be keep running until maximum iterations are reached. And here at this point, let me click on continue. FIT, and we are considering here the FIT, the first fitness value which we get from the first 30 positions. Okay, and we have considered this as the fitness, which is actually the fitness, and now updating the alpha, beta, and delta. And here is some probabilistic or evaluation for these parameters alpha, beta, and delta. We have to update its values. So if alpha score, which is actually infinite, is less than fitness, yes, it's less than, so we will just update that. And the position score, so the fitness will be into the score, and the position, the 30 numbers will be into this position. So these 30 numbers, these first 30 numbers are going into the alpha position, and the fitness which we get from this first number is going into the alpha score. And previously alpha score and alpha positions, previously it were be zeros, and let me select the alpha score, and previously alpha score is the infinite and alpha position are zeros. So we have to just update that them, and let me show you now. Now alpha score is changed from infinite to this number, and alpha position is also updated from zeros to this number. Similarly, these another, let me click on step, and if our fitness is greater than alpha score, yeah, it's updated, and fitness is less than beta score. Our fitness, let me choose that, and beta score is our fitness less than, yes, this is true, and so it means that this condition should also be true, and this condition should also be true. So our fitness, I move my cursor over there, and here you can see the number. So this number is less than the infinite, and the fitness should be greater than this thing, and it's our same. So this will not be converged, yes. And here in that case, and this should it means that this and all three conditions should be correct. And if any one of these three parts, first, second, and third, any one of these is not correct or satisfied, then this condition, then the code will not update the delta score and delta position. So let's fitness is greater than alpha score. No, it's not correct. Fitness is greater than the beta score. No, it's not correct. So this is not going to converge. So here is the end of the loop, and be this loop will be keep running up to the 30 times, as I previously have checked that the 30 its size is 30 multiplied by 30, and we have to find the size. So this loop will keep running 30 times. So let me get out of this loop. Let me click on continue, click on continue. Okay, we are out, and let me see, is it updated? Yes, it's updated. Beta score is also updated. So our alpha, beta, and delta rules are now updated, and now we have to calculate the candidate position XIGWO. So it's the next phase of this IGWO. Okay, and let me explain this part in a simple way that initially we have initial numbers, these numbers, and using these numbers we have updated, we have evaluate the fitness function, and the fitness function is stored into that. And that is actually the initial position of our wolves in this case. And here in XIGW, uh, before XIGW we have just do a little movement in the numbers of in the location of these wolves. We have just updated the beta, alpha, and the delta. And after that we have I mean after the algorithm execution, we have updated or move our current position to explore and search for the better solutions. So in this way, in to calculate the candidate position XIGW for a wolf, we use the algorithm movement rule, and we have update the current position. And the updated current position which we will update here in this, so this will be the update positions for all the wolves, and this thing is labeled here as XIGWO as the updated positions. So here we have decrease linearly from 2 to 0. And let me click on step update the position for each search engines, including omegas and some omegas calculation. Click on positions and position 1. Okay, and 30 for, let me show you that. So we have to run this loop for 30 times and 30 times. So here is some MATLAB code part for this section candidate position where we have to update it. So R1 is a random number in 0 to 1. Yeah, any number with rand. So let me click on step, and R1 is just a number, and it should also be a number. Let me click on step, and here is some further evaluation. Click on step, and here is some equations. Definitely there is a reference paper, and that you can just take a look at in more detail about these equations. And then we have some further equations to evaluate this part. Beta position, so based on this, so now we are just updating the positions for alpha, beta, and delta wolves. And here is the x. We have initialized this variable here. So this is the point where our first loop is going to be is ending. Okay, let me out of this loop. Let me click on continue, and here right at this point we have, here we have I is 1. Let me copy that, and let me see the size. This variable, it have 1 row and 30 columns. So here you can also see that there is XGWO. So we have 1 row, and we have 30 columns. Let me click on continue here, and again this time I have 2, and we have another 30 numbers. So means when we will this each time this loop is ended, we will get another 30 numbers. So as these loops have to run for 30 times, this one have to run for 30 times inside this. So each 30 times when this will be completed, it will be another loop. So this initially it will be the first one, and it will run for 30 times, and then it will be 2, and this will run for another 30 times. So each time, let me click on continue, we have another 30 numbers. So that 30 numbers, and now we have to put that into our FOBJ means let me click on step, and now I have to put that 30 numbers into FOBJ, and which is actually the evaluation for F1. We have to evaluate that here. For each 30 numbers we have to find the fitness, and that fitness is now stored into the FIT Let me show you that too. FIT. So we have run this for you can see that two times. Let me click on start. Right now we have 3 rows and 30 columns, means we have 3 times run. We have 3 wolves. Let's consider wolves, and here we have 3 fitness values for them. So let me out of that, let me remove that, let me click on continue. So now here we have the x, these are the updated numbers. That's why we said it as XIGWO. These are the updated numbers, and these are the updated fitness values for it. And now here at this part we have calculate the candidate position XIDLH, which is the another part, which is another phase, and here is some equation. So yeah, there is a some part missing, and at this point we have another function call that is bound constraint, and in bound constraint we have another check the lower bound and checking the upper bound. So here is some kind of validation that our bounds are within the range which we have initially um, assigned or we have allocated. And then here is some the calculate the candidate position XIDLH, some calculation for that. This is actually uh, copy that. So this is the pre-default pairwise distance between two sets of observations. So this is the pre-default MATLAB instruction. So it means, and based on these calculations and evaluations we have another XDLH. Just like XGWO we have another phase, and that phase is XDLH. So this part actually is about the finding the candidate position for the next step within the optimization algorithm. It's just updating the numbers based on the previous results. So here at the end of this program, let me click on continue. So right now we have X, just like XGWO we have XDLH, and here there is a selection that which one is giving us the better, either DLH is better or GWO is better. So let me click on here FIT GWO. These are 30 numbers, and these are also the 30 numbers. So that is actually saved into the TMP, and now based on the yeah, it's giving us every time FITGW is 6.5136, and it's uh, yeah, it's e raised power 4, and this is e raised power 5. So this is more, this is a 1.55, and this is the 6.5. This is 10 raised to power 4, and this is 10 raised to power 5. So this is less, so it give us all the numbers as 1, means the condition is true. So now we are going to create this thing, and let's see, this is our 30 to 30, and we are, let me open that temp. So these are the logical numbers, so it give us that all the conditions are satisfied. And then there is some more part of it for the selection criteria. And now at this part we are just updating our pbust score. So here pbust score is updating. Let's click on this tab, and it's just updating the fit and the pbest score and pbest. And this is the next iteration. This is the end of the while loop. This will be keep running and until we have our maximum iteration are reached. And at the end of this loop we have to give them this part alpha score, alpha position convergence curve, and all that stuff. Let me click on continue. Okay, now we are out of this loop. So we have just updated our the f best, l best, and convergence curve, which was actually in the IGWO as the. So here it was actually the alpha score, alpha position, and convergence curve. And here in this program we just rename that f best, l best, and the convergence curve. The f best is actually this is a variable which contain best fitness value we find by the IGWO. And this l best, it's actually the stores the best solution that actually correspond to that f best. And convergence curve will store a sequence of fitness values over the iteration. And next after that, let me after that, here we are the displaying the L best, the best solution obtained by the IGWO, and the best optimal value of the objective function, which is actually the f best. Let me click on step, and then this is the range, means x-axis and the y-axis positions. Let me click on step, and here are some other functions and their representation into this plot. Let's click on continue, and here you can see this is the plot which we get from this function. So hopefully you enjoy this video, and if you want to fit your objective function, you have to just put your objective function, or you just have to work on this function file, and you needs to fit your function into f1 and follow this procedure. And that's how you can fit your objective function and perform this IGWO optimization algorithm to your case. So please like the video and share it with other colleagues. Thanks for watching.